In this video, you are going to learn about compound inequalities, and specifically we're going to focus on compound OR inequalities today. The definition of a compound inequality is an inequality joined by and or. Now, the first example is an example of an and inequality, which we learned about yesterday. Today, we're going to talk about the OR inequalities. Now, in order to graph a compound OR inequality, you're going to graph the two inequalities separately. So to graph x is less than or equal to -2, we're going to have a closed circle at -2 and draw our arrow pointing to the left, since our arrow points to the left. Then for x is greater than or equal to 4, we'll have an open circle at 4 and draw our arrow pointing to the right. This is our solution. Since there's two separate inequalities, they point in two different directions, it's going to continue forever in opposite directions. Your way of remembering is thinking of it like oars on a boat. Just like the boat we have below, the oars point in opposite directions, so an OR inequality should point in opposite directions. Now, if we are going to graph a compound inequalities, and this combines both and OR, our first example is an OR inequality. So we're going to graph them separately. So we have x is less than or equal to 0. So I put a closed circle at 0, draw my arrow pointing to the left, and x is greater than or equal is greater than 2. So I have an open circle at 2 and draw my arrow to the right. For the second one, this is what we would consider an AND inequality because that x is in the middle. So in order to graph that, I put an open circle at -4, a closed circle at 4, and again, because it's an and x is in the middle, that means we're going to shade the middle. The next one would be considered an OR inequality because we have our two separate inequalities. So x is greater than or equal to 5. We're going to put a closed circle at 5 and shade to the right. Then it says x is less than or equal to -6. So I put a closed circle at -6 and shade to the left. Our last one is another example of an AND inequality because we have the x in the middle, so we're shading between. So I put a closed circle at -3, an open circle at 1, and we shade the area in between the two. Now, in order to solve a OR inequality, you want to solve and graph both of the inequalities separately. So if I wanted to solve the inequality on the left, to get x by itself, I would first subtract 9 from both sides. So you have -6x is less than -6. And then to get x by itself, you would divide both sides by -6. However, because you are dividing by a negative, that means you have to flip the inequality sign. So it would become x is greater than 1. For the other inequality, to get x by itself, we'd have to add 8 to both sides. So -3x is greater than 21. And then divide both sides by -3. And again, since we're dividing by a negative, you have to flip the inequality symbol. So you would have x is less than -7. Now if we were to graph, we have -7 and 1. Our first inequality, we'll have an open circle at 1 and draw our arrow to the right. And for the other one, we're going to have an open circle at -7 and draw our arrow to the left. For our last example, again, we have to solve both the inequalities separately. So to solve for x on the left, I would have to divide both sides by 3 to get x is greater than 5. And then on the right, I have to divide both sides by -2. Again, since we're dividing by a negative, you have to flip the inequality symbol. So you'd have x is less than -2. Now if we're to graph, we're going to have an open circle at 5, and draw our arrow to the right, and you'll have an open circle at -2. Draw your arrow to the left.